Hi everyone, this is Jared, AC7WH Backyard Ham Radio. This time I'm going to be doing a sort of lab test in my room here in the ham shack. And I just want to see especially what sort of difference it makes with the shape of an antenna. Now this is a very simple setup. I am considering doing the same test again out in the real world where I normally set up my antenna. But I'm curious to see if I have approximately a quarter wavelength antenna, what sort of difference will be made by just simply changing from a straight line, more or less, similar to a horizontal or vertical driven element, to a semicircle, for example. So this is just using a very simple setup. This is a mag mount, just braced horizontally here. Fully collapsed vertical antenna, mostly just for a simple connection point, just for what I had available rather than having to disconnect any other coax or anything like that. And I've just got it run over to here. So the red insulated wire is a quarter wave 10 meter antenna, but then this part here I have just for connection purposes, just for testing it with my rig expert. Okay, I'm going to pause here for a moment and let's take a look at what sort of readings we get this way, and then we'll compare it with the antenna in a loop or semi-loop. All right, let's take a look with the rig expert AA35 zoom. Okay, we're going to go ahead and try the SWR chart. Okay, minimum SWR is a 2.0, not terrible, but of course this is just a test bed setup. So a 2.0 at 14,760, and then it dips again up here in the 10 meter band. Resonance-wise, let's take a look at that. It's resonant at 8977 kilohertz. If I scroll through, there's another resonance point at 28299, similar to where we saw that dip with the SWR. Okay, keep that in mind. I'm going to change up the antenna and let's see what happens next. Alrighty, this is a much more physically compact design. It's the exact same wire, exact same setup, exact same hookup, all of that, but now it is in a semi-loop. Now, not a complete loop, because I am not trying to get any more inductance than necessary, but I want this to be circularly polarized. Now, of course, this is horizontal on the floor, even with a shoe on it to hold that wire from trying to curl up. But let's just see how this does. Now, as you can see here, this is a relatively small size, and that's a quarter wavelength for 10 meters. I mean, that's just a standard shoe size down there. Look at that. I mean, not very large at all. Giving a more zoomed out view. It's not very big. But that is a quarter wavelength on 10 meters. Let's see if having that same amount of physical wire and the antenna vertical fully collapsed there, telescoping antenna, as kind of the feed point off of the mag mount, just for simplicity's sake tonight. Let's just see what ends up happening with the SWR and the resonance for this. I do not know yet. I have not tested it. Let's find out. Okay, I'm back over here with my AA35 zoom. Let's see what kind of reading we get here. All right. Kind of centering this here. Let's do the test. Look at that, almost identical. 2.1 at 14,760. Let's run it one more time just as an example. Yep, holding steady. 2.1 at 14,760. Almost the same SWR, so 0.1 difference. And again, it's dipping over here around the 10-meter band. Not quite the exact same pattern, but certainly similar. Let's check out the resonance. Okay, 8981 is that one point, and 28157 is the other. So not identical, but very similar. So what does this tell me? This tells me essentially that if I were to use an antenna of an unusual design that has a long enough driven element, I can get a similar SWR with a very different shape. And so that encourages me to try different things like my crossbeam antenna and to try other loop designs. Now, I wouldn't recommend doing multiple loops that are too close to each other, or if possible, if you can avoid having it too close to other wiring and metal objects, but keep in mind, everything affects everything with antennas. So obviously here with metal things around, there's going to be a difference in how this reacts compared to if it was out in free space or semi-free space. However, just a simple little wire like that, I mean, think about that. You could just hide that almost anywhere and use that for 10 meters. And it's pretty cool too, because that is 14 gauge wire. It's not some thin spindly wire, so it can handle some power, but still you have to be careful with it. Anyway, that's my experiment, and I'm very encouraged by what I see. This is AC7WH Backyard Ham Radio 73.